Welcome to Turn Right Machine Works. My name is Keith. And before we get going on the video today, I'd like to go ahead and give a plug. I'm plugging for Mr. Pete. Mr. Pete has put together some very nice quality videos, course style, which is something that I'm not a course person, okay? And he has put together videos that, one, have got phenomenal detail, very clear instructions and information and tips, and all the information that you need to get comfortable with the lathe and know that lathe pretty much inside and out before you even step up to it. Or if you have one and it's sitting in your garage and you want, where do I start? Or I'm just saying, because there's a lot of youth also, I'm asked time to time, I'm interested, where do I start? Mr. Pete's videos give you a place to start. They give you a place to actually go back and kind of refresh yourself. There's a lot of things that you'll take for granted or slip your mind, or you bypass it, or you might, some of the things that he covers within the lathe will keep you safe. Keep your machine in good condition. It will get you familiar with every operation of the lathe. So let's take a look at it at the screen right now. And this is LFE, and this is Machine Shop Courses. And here is the link to go for it. Alright, now also, and I'm not going to get into, hey, you've got the picture right here. I'm going to give you this promotion, and this is 20% off Mr. Pete's courses when you check out, and here is the code. Alright, I have to put that plug in because I believe in it. I believe in LFE, and I believe in Mr. Pete and the courses, and I also believe that we need to keep this trade going because just all the input from all of you out there and everything else. And you don't have to be a flat belt genius, and you don't have to be a CNC operator. It's all combined, and it's important. I think it's important for old school to be mixed in with new school. All right, there's my bid on the promotion now. All right, we got this 2 bars in here. We got to do some hog milling. A lot on one because we got to take it on down because it's going to be just slight different rectangle than this slab is here, but the material available was all in one size. And then after that, then we get a little L notch cut out. We're going to be milling the full length of this, and these are some pretty big pieces, and we're going to be sliding them on the mill table, and we figured out our combinations of being able to slide it and move our head and rotate the parts around and all of that, that if we go ahead and create a hold down at each end in the center and weld it to this each end, that we will be able to hold this down on the mill with minimum amount of mounting and also obstruction, because we were going to run our large shell mill and some big cutters, and we're going to flood coolant our cut, and we want to put our troughs in the table, and we make the job more comfortable. And first thing this morning I was whining because I thought I'd have to cut some pieces and put some holes in it, and I looked up there where all my mill clamps and everything else are, and sometime I threw 4 exact matching pieces of what looks to be cold roll precision hole in it, exactly the same size. So we're going to go ahead and we're going to put these on each end. Now when I clamp or I weld things to clamp on the table, I like to always have a positive hold. Sometimes if you weld, you just put something against it and you weld it, the thing is actually floating up off of the table, and it's only resting on these 2 pads right here, and you get harmonics and vibrations and things like that. So what I'm going to do is I take 2 pieces of strapping, which are about 15 thousandths on the thickness, and I go ahead and I put those underneath here, and then I clamp this down to there and then create the weld. So that when you remove the 15 thousandths, you have this down on there, there's a positive pull of the actual piece or the part you're trying to cut down on the table. Alright, so let's go ahead and we're going to get these centered up and get them clamped down here. Nothing really fancy about this whole operation here. We just want to make sure that they are in there. All right, now these things are exactly ½ inch in from each side, which makes it real easy. The width of a machinist scale here is ½ inch. I'm happy with that. All right, we got to move our clamp back because we're going to be putting weld in here. And then we'll run our clamp like that. Be a little easier. And we need to just move that just a little bit this way. That looks good. Close. Alright, same thing on this side. And we'll go ahead and we'll start our clamp sideways right off the bat so that we don't run into that problem. Alright, we got those clamped down with our 15 thousandths strapping shims underneath there. And I think we're ready to go ahead and weld those up. And then we'll go to the other side and we'll weld another pair on the other side there. Alright, now I'm going to stick weld these just because that's my preference of welding for structural and strength. And I'm just going to put a round on there. And I'm going to grab rod here out of the oven here. You do have to switch your machine over to remote and switch a few other things there. Okay, should be ready to go now. Okay, just one good single beat across the top is going to be enough to hold this thing down here. And we'll switch our lead over to this side here. And seem to have a little bit of a flex problem there. Alright, we're going to go ahead and switch our rig around and get the other side set up. Do the same thing. Alright, I'm got the second side set up here. I'm real happy with that. So let's go ahead and establish our fresh rod and go ahead and hit this side. hammers are always pretty good about making a good solid ground for you. Come on, baby. You ever have one of those logs that doesn't seem like it wants to start right? Alright, we are set up for milling now. Not much weld, they're not real hot then. Alright, and my chipping hammer's in my bag, so we're just going to use the little putty knife here. Just take a little bit off here. Nothing fancy to write home about. That's the one I started and I had the sticky start, but I was able to melt it in and smooth it out. Here's the other one. Now we're not going to bother going down on the side here at all, because we are just held down, and I can feel the surface underneath here that I'll be drawing it down. All right, let these cool for a second, and we'll go in and start getting set up on the mill. Welcome to Turn Right Machine Works. My name is Keith, and today we're getting ready. We're going to do a little milling in the K&T, and we're going to do a little milling in the Bridgeport there. I get asked time to time, you know, compare one mill to the other. You can't really compare them in a sense that which is better. Okay, they both have their own uses and their own size of type of material and their operations. Alright, now I'm going to have a couple different things that are exactly the, you know, pretty much kind of the same type of work on two different sizes of pieces or whatever, and we just got back from welding our ears on these big slabs here, and we're going to be doing some shell milling first. And over in the little Bridgeport there, we got a little we have a 4-inch shell mill here, and over in the Bridgeport we have a little 2-inch shell mill. And we're going to be doing kind of the same thing at both locations there on two different jobs. Alright, so we're going to go ahead and we're going to get the studs and hold downs in here now. And this lets us start at the top right here, and we're going to work our way that way, turn the part around and come back the other way, and do this job in half and half. And we're taking this down in the height that we need, and then we're going to go ahead and we're going to be putting a little notch. We have this piece here and a piece that we don't have to actually machine anything off of this top here. We just need to go ahead and make the notch. So we're going ahead and we'll get this locked down. Okay, and we're just going to kind of eyeball this thing side to side. We got a width wider than we're going to be running. We're going to be endoing this thing, so it's just not 100% perfectly in line as needed. We can just go ahead and just, we got these troughs here so that we can run coolant on this thing, and hopefully really get some hogging going on here. Alright, now this should be pretty well stout to the table here. We're going to go ahead and we're going to switch you around here so you can see more. Alright, just to get started, basically I'm just giving myself a free dial here and medium tension on all of our locks there. Alright, I'm going to bring this down underneath here and I'm just kind of touching off on this and kind of happy with that speed there. We're going to start out just about 153 RPMs or so. Okay, we're just barely touching that. I'm not going to do a whole bunch of rubbing there. I know I'm real close. We're going to set it at 0 there. Because I want to go ahead and get that. I just put these inserts in here the other day, so these are pretty well a fresh pair of inserts. Alright, we're going to bring down a little coolant here. I'm leaving the coolant in on the inward side of the cut. I kind of always like it. If I was going to go that way there against my part, I would put the coolant over here so it comes in. That way you know that you've got the moisture in on this side here. Alright, we're going to go ahead and we're going to crank it a 1/4 inch here. And we're going to start it out at a 1/2 inch a minute speed here. That's the aluminum singing there. I'm going to see about a narrower drop on the back side there. Alright, I got a little narrower drop here. I'm going to try to see if we can get a little better. And I'm going to go ahead and crank in 1/8 of an inch here this time. And a 1 inch a minute travel. Alright, that's a lot better. came in at 8 that was looking really good. We dropped down to the other 8, and now that we don't have that aluminum under pressure back here, it was wedged underneath there, so it was given the howling. I'm gonna see if this might take the load here. Okay, we're coming up to an 1/8 of an inch away from picking up the second 1/8. That's 16. Okay, we should be right there. Okay, not gonna take that whole thing. So we're just gonna go 1/8 of an inch at a time here. It does run smooth. We can probably increase our feed rate a little bit. Let's go up to 1 3/8 speed here. That's pretty quiet. We're actually starting to see a smoke over here on the pile. That's a pretty good chunk without really punishing it. All right, so we're gonna go ahead and we're gonna let it run at that rate right there, I think, for the job. Okay, while that's running over there, we're going to go ahead and set up here. We have a couple old keys. These are out of an old antique tractor, and he's got a different modification of a hub there, and we're going to make 2 step keys, but we got to take down the height first. Of course, there's a little bit larger shell mill here, and I don't have like a 1-inch end mill or something available at this moment here, so we're going to go ahead and we're going to use the 2-inch shell mill here to go ahead and mill this down to height here. Well, I came over here to put this is a clamp. This is a real old tractor hub. Alright, and the hubs used to clamp onto a shaft, and then the rim or the tire or the wheel of the tractor would bolt to that. This is a stub shaft that was cut off because he's modifying the width and the drive on the tractor. And I had this in here, or he had this in here, and he said match those keys. Well, this is 2 5/16, and his bore is really supposed to go on 2 1/4. So he's going to be bringing over the other hub, and we're going to be setting these up with a spacer in here. We're going to be boring out these to fit his 2 5/16 diameter axles, and then we'll go ahead and we'll make the key. So we're on hold on the key for right now. We're going to continue on our other project. Now this has been running. This is a 1/2 inch down so far from our overall height there, and we got another half to take off of this, and then we're going to turn it around and work it. And we've been vacuuming up our chips in between each cut, and it's still holding good, and it's 1 3/8 per minute of travel. At 153 RPM.
good combination. It's not really pushing it. Got a nice quiet. I think it's adequate. See how that lifts there? Because when you relieve and you cut on the materials, you relieve that material here that's holding it down this way here, and it wants to spring back this way here. It would kind of equal out if you were cutting off of both sides, but the thing does have a little bit of a rock now because we relieved the pull on half of this side here. This is going to get cut in sections there when it's all done. Mom let you out of the house, huh? The weight for a piece of material to be an inch narrower in this one direction would have taken forever, so that's why we went ahead and take the choice of the material, which is not that much more for it, and go ahead and take a little time and just whittle that down. That's why we're doing these two cuts, two sections right here. The rest of it we're going to set in the turbo windmill, and all we got to do is put in a little cutout, and then we'll be good to go. Alright, we got this done. We're going to get ready to pull this out, but we're just loosening up that in there. We're making a trial run here to try to get dialed in. We got about 0 there, and it's coming on up to about 20, 30, 35. It kind of levels off, and it starts coming back down a little bit. So, it really only is about 10 or so out, but it does have a little bit of a dish. about 25, and it comes back down to 0. All right, we're going to call that 0. All right, I kind of like this. If you got the V block, style mag base, you can actually put it right on this, and then you can curve it out of the way. You can leave it up there if you wanted to, but most of the time it's out of the way. You don't want to ever knock your dial off and hit the floor. Even when it does happen, kind of hate life. Waves are still looking pretty good on this old beast here. Alright, we're going to go ahead and pull this out. We're going to throw in our turbo end mill. Well, I thought we were going to be running my 1-inch turbo here, but it looks like we've got developing severe teeth on the end down here. Even though this is good up here for reaching in a slot and slotting, it's not really ideal for what we're doing. So we're going to go ahead and we're going to drop it down to a 3/4, and we're going to run this one here. trying 7/8 deep, 1.25 depth of cut. I would say we're going 7/8 on the width, 1/4 inch on the depth, and right now we're at a 1/2 inch per minute. And this is the groove that we're actually shooting for. If I had another turbo end mill, I'd probably push it a little bit more and we'll see what we could get out of it. But I got 2 parts that I need to make some metal remove, and I don't care the speed. If it's a little slow, it doesn't matter. I need to get the job done. I cranked it up to about 5/8 of an inch per minute. Every once in a while, a little light puff of smoke. Go to 3/4. Alright, there's 3/4 inch per foot. Going back for cut number 2. Another 1/4 inch cut, and then the last cut we come by will be 1/8 of an inch deep for a finished cut. Okay, we're at a 1/2 inch on the depth here. We just need to go to 5/8, and we're just a little bit better than 7/8 on the depth there.